Stay tuned. There is no coding interview without Java collections. In this chapter, we're going to talk about collection framework and related topics. Continue watching.
In this chapter, we're going to talk about collections. We'll understand the definition of collection after a couple of videos. In this video, I'm focused on making you understand what's a list. And for that, I would like you to open this file, list example, under the project collections. Let's expand it. A list is more or less similar to our regular arrays, except array is of fixed size and the list is of variable size. If you're defining an array, you need to tell the size of it up front. But whereas for list, as and when you add new elements into the list, the size of the list will keep expanding. We had already taken a look at one of such example, which is ArrayList. Let's make use of that class to create a list of elements. So I'm going to say ArrayList, I'll call it list equals, I'm going to do Ctrl+Shift+O to import the ArrayList class automatically, and I'm going to say new, Control space would give me suggestions. I'll choose ArrayList. Now this list will allow me to add any kind of elements into it. I could add a string, I could add an integer, or I could even add my own objects. But we don't want that because there are some problems associated with this approach. As we had looked at in our previous chapter, when you have a list in which you can add any kind of elements, then you will have the trouble of typecasting each of the element when you read the elements from the list. So in this case, we want this list to be of specific type. For example, I'm going to make use of the type argument to say the only type of elements that can be added into this list is of type integer. Now you have to define the same thing in these angular braces, but compiler is smart enough to understand that you don't have to tell that. So now this list will allow us to add the integer objects, and I'm going to make use of the add method to do so. I'm going to say 10. I'm going to copy paste because we wanted to insert multiple elements. I can say 20, 30, again 20, 40, and say another 40, whatever. When I send these integers, compiler will implicitly create an object of integer. For example, the 10 in here is equivalent to new integer of 10, but we can just simply say 10 and compiler will do the job for us. Also now, as you would expect, we cannot pass any other type of argument. Now we can use the sysout statement to just simply print everything that is inside this list. Let's run the program. There it is. Also note that the order in which these were printed is the order in which we have inserted into that list. So what has happened right now is when we call the list and we pass it as an argument to the sysout method, internally this instruction would call the toString method inside the ArrayList. And what does the toString method do? It will print all the elements in the list in this format. Let me demonstrate you by adding our own type of data. Let me just create a new class. I'll call it my own. Inside this, I'm going to have a variable, say int x equals, I'm not going to assign anything. I'm going to set the state with a constructor, my own, and this is going to take one argument, and inside this I'm going to say this dot x equals whatever the argument that this constructor takes in. I'll do Control Shift F to give proper indentation. Let's make this variable public. Now let's go back and try to create multiple instances of this class. So I'm going to say my own O1 stands for object 1, new my own of 10. Similarly, I'm going to create a couple of more objects. I'll call this O2 and O3. I'm also going to create another list, or rather let's make this list of type my own. So this list would now only accept the object of type my own. Let's keep adding. So this will allow us to add O1, O2 and O3. Let's get rid of this. Now if I try to print the list, it's going to show us some random generations. Let me show you. So basically Java does not know how to print these values because this is your own object. We need to tell Java Virtual Machine how to display my objects when we wanted to display them. By default, it's going to display the class name at the hash code. We've already talked about it in one of our previous videos. But the thing that we want to do here is to make use of a method called toString. Basically, we're going to override this toString method. For that, I can certainly make use of our IDE. So I'm going to say override implement methods. I'm going to say toString, and toString is a method of object. Now in here, what I'm going to return is simply the value that we set, x for example. Now we cannot send integer because the return type that is expected in here is the string. So we're going to say integer dot toString, and I'm going to pass in this x as an argument. Oops. Now this should return the string version of whatever we set in here. Let's run the program. Now hopefully we should see a meaningful output. There it is. Let's have some random values in here. Pretty well and good. But definitely printing the list right away is not meaningful at all. We wanted to do something with it. Maybe we wanted to do some calculations. And for that, let me just undo all these changes and get back to our integer list. So what I wanted to do here is for each one of these elements, I'm going to add the value 10 to it. And for that, I can certainly make use of the for loop. I'm going to say int I equals 0, I is less than the list.size I ++. In here I'm going to do sysout. I'm going to get the ith element dot get, index is going to be I, and plus 10. Let's run the program. Pretty well and good. There's actually a better way of looping through all these elements. We'll talk about it maybe next video, but for now this should suffice. You can also explore all the other methods inside the ArrayList class. For example, we can say list dot, you got a lot of methods in here. You can always go through each one of them and read the description and use them as you would require. For example, I'm going to say I'm going to make use of sublist method. I'm going to say 0 to 3 or whatever, and in fact let's wrap this around the sysout statement. Let's see how the output looks like. We have one serious problem here. Let's say that you found out another class which is providing the same functionality that ArrayList does, and apart from that, it is providing some additional functionality. So you wanted to switch to that implementation. For example, there's a class called vector. Now this is going to provide the same functionality of ArrayList, except it is having some additional capabilities. For example, you can get the first element by doing so, and obviously you can make use of sysout statement like so, and you can print. Let's comment this out. Let's comment this out as well. So I print the first element. But the point I want to make here is, let's say you again change your mind and you decided to use the ArrayList because you found out that ArrayList is much faster compared to the implementation that vector provides. Then let's say you wanted to switch to ArrayList. You're going to say ArrayList again. You're going to do Ctrl+Shift+O, but we have a problem here. The ArrayList does not have this method, first element. Now imagine that you have used this list across your project, which would constitute millions of lines of code. Then this is going to pose a very serious problem. Wherever you have errors like this, you need to fix it and try to provide similar implementation. This is going to be a very tedious job. But we have a solution for that. All these implementations like ArrayList, vector, or there is another implementation called LinkedList, they all implement one interface that is called the list interface. Let's do Ctrl+Shift+O. The list interface is also part of the util package. Now by doing so, you're forced to use only the methods that are residing inside the list interface. So now you have to get rid of this, and let me uncomment these lines of code. Let's save the file. Your program runs smoothly, but tomorrow if you decide to use somebody else's implementation, let's say you wanted to switch to vector, it will work smoothly. All that you need to do though is you need to import that class, and that's it. You don't have to make changes elsewhere in the program, because be it vector, linked list, or ArrayList, all those implementations must and should provide the implementation for whatever the methods residing in the list. And you in your code, since you have the interface as the reference type, you have no other alternative but to use the methods inside the interface. So the list interface is kind of like a set of standards set for all the people who wanted to provide implementation for list functionality. So it's always advisable that you use the list, or it will affect your project badly at later point of time. Alright, see you in my next video. In this video we're going to talk about set, and for this example I'm going to make use of the exact same code what we have in our list example. Let's get rid of this for the time being. Instead of list I'm going to call it a set, and instead of ArrayList I'm going to say HashSet. Basically HashSet is a class that provides implementation for the set interface. Of course we need to import both of these. So what is a set? A set is similar to a list, except it differs in terms of two aspects. Number one, it cannot have duplicate elements, and number two, the order in which the elements are inserted may not be the same order when we read the elements from that set. Let me show you what I mean. I'm going to make use of a simple sysout statement to print this set. By the way, let's call this set instead of a list. That would make more sense. Let's save the file. Let's run the program. My first element is 10, but what we have here is 20. So the order is not guaranteed. Also, this set of elements does not have any duplicate values, any duplicate objects rather. We have added 20 twice. We've also added 40 twice, but they are being displayed only once. And with that, set cannot work on indices. For example, like we have here for a list, like list.get, we cannot have such method in here. That method is not supported because, let's say I make this 6. What I would expect from this instruction is it would get me the element 40, which is at index 6 if you look at it. But when the program is run, all the duplicate elements in the set are eliminated. Also, the order in which the elements are stored in the set is not the same order we add them. So it doesn't make sense to have this method to get an element at a particular index. And with that being said, we cannot use something like the for loop in here. Let's do Ctrl+C and Ctrl+V. We cannot work with for loop here because we cannot get the element at a particular index. But we have an alternative. We're going to make use of something called an iterator. So we're going to say iterator. It's a class. Let's call it itr. It's not iterator, it's iterator. Let's do Ctrl+Shift-O to import this class from the util package equals, and I'm going to do set.iterator. We'll understand what is an iterator. Now this method iterator of the HashSet is going to return an object of iterator. What it's going to offer is an alternative solution for the for loop. Let me demonstrate you what I mean. There are a couple of methods that we're going to make use of. Iterator.next. What this is going to do, returns the next element in the iteration. Let's try to retrieve the element. Let's do sysout and let's print what it is returning. So now what this is going to do is it's going to return the first element in the set. And when I call the same method next on the same object itr, then this is going to return the next element. So let me just demonstrate you what I mean. If I run this program, this instruction return 20. The next time I call this method next, it's going to return the next element in the set. Similarly, we can call all the elements and we get all the 4 elements that are residing in the set. If you try to call any additional element which is not present in the set, because as we know that some of these elements are deleted due to duplication, so let's run the program. We're going to get an exception. It says no such element exception. So to get rid of this kind of exceptions in our program, there's another method which we can check to see if there is next element available. So if itr.hasNext is going to return a boolean value, and it would tell if we can use the method next. So only if this is true would we want to get the next element. So this is going to solve our problem. Let's run the program. This time we shouldn't be having an exception because in here this is false, condition didn't met, and this statement didn't get executed. However, we don't want to do it this way. We want to make use of some kind of a looping construct. We want to loop through each and every element in here and kind of perform some operations. We can certainly make use of while loop or even for loop. I'm going to make use of while loop. So I'm going to say itr.hasNext, and I'm going to say sysout itr.next. Now this is going to return the next element in the iteration plus 10 or whatever you want to do. Now this is going to be an object, hence we need to perform typecasting integer. Let's get rid of this code in here. Now run the program. There it is. The result is as expected. So this hasNext is going to return true if the iteration has more elements. In other words, returns true if next would return if the method next, which we used inside the while loop, would return an element rather than throwing an exception. But let's see what will happen if we don't make use of this next element. Let's get rid of this. Now this is going to be an infinite loop. That's because since we haven't read any elements using the next, the hasNext will always return true. Let's run the program. Obviously this goes forever, then we need to explicitly stop the program. Alright, now this explains the difference between set and the list. Also there is a shorthand way of dealing with iterator is by using something called for each loop. Let me show you what I mean. I'm going to say for, and we're going to say the type of data, the type of elements present in the set, and let's say I or whatever you want to give. We're going to use a colon, and then we're just going to pass in this set object, and that's all there is to it. And you can do exact same thing what you're doing here, and instead of itr.next you can say simply I variable. So you can think of this statement as a shorthand for writing all this. So internally this is going to use iterator. Also this is visually more readable and maintainable. So what this means is for each element I of type integer in the set, we're gonna do this. Let's run the program. There it is. In fact, although you can use for loop for ArrayList, it's always advisable to use either iterator or the for each loop. We'll see why at later point of time once we cover rest of the topics. Okay, lastly, there's one downside with using for loop over the iterator. In iterator you can actually make use of the remove method to remove an element, but whereas in here we cannot accomplish the same. For example, I cannot say I.remove or whatever because the I is of type integer. But anyways, you always have workarounds. For example, you can use the remove method in the set, remove, and then you can tell the object to be removed. But it's a bad practice to use. In case if you're dealing with removing elements, then you are better off use the iterator than the for each loop. Hope that makes sense. We'll talk more on iterator at later point of time. See you in my next video. In this video we're going to talk about map. You can think of map as a list which will have elements, except each one of those elements would be identified with a unique key. Let me demonstrate you what I mean. So first of all we need to create the map, and the map class will allow us to send a couple of type parameters. I'll say string and integer. Basically the string would be our key and integer would be the type of the element that we're going to insert into this map. Map equals new and we're going to use the implementation of the map interface, which is HashMap. That's it. Let's do Ctrl+Shift+O to import required files. Now we're good to go ahead to add elements along with their associated keys. So the way we do it is we do map.put. We use the method put to put the key. In this case it has to be a string, so I'll say 100, and the value is going to be of type integer, say 10. Likewise, you can keep inserting as many elements as you want, but make sure that the key is unique in each and every entry. By the way, together these two are called an entry. So let's make this 101, 102, etc. Let's say this is 11 and this is 16 or whatever. Now let's just simply try to print this map. Sysout map. So this statement will actually call the toString method of the HashMap. Let's run the program. So key value, and key value. Let's see what will happen if we have the same key for a couple of entries. In this case, this statement will remove this element from the map and it will place itself. Let's run the program, and we should see only 2 entries in the map. There it is, and this is the latest one. And obviously you can always have the same value. That shouldn't be a problem. Only key is supposed to be unique. So basically you can think of these keys as an identifier for the values. You either update, delete these values based on its corresponding key. Now let's see how we can retrieve a specific element from this map. For that, we're just going to make use of a method called map.get, and we're going to pass in the key. In this case it has to be a string. If I say 101, it's going to show me the result of 11 because that's what its corresponding value is. In fact, it makes sense to call this a map because it is kind of mapping both keys and values. Hope that makes sense. Now obviously we don't want to just print the map, we want to do something meaningful. We're going to use a looping construct, and just as I had explained, we're going to make use of for each loop. There are a couple of ways you can make use of the for each loop. One is you're going to loop through all the keys, and in order to get all the list of keys available in the map, you just have to say map.keySet. This will bring us a set of keys. Now what we want to do is for each and every individual key we want to do something, and we know that each one of these keys are of type string, and using a colon we can get each one of the keys from this key set one at a time and do something with it. So in here all I'm going to do is sysout and then map.get of s. Now this s can be anything, you can call it key or something. Let's run the program and you would see all the values. Pretty well and good. Now I said both key and value pair together called an entry. We can loop through all these entries using the for each loop. Let me demonstrate to you what I mean. So for we need to get the entry set, and what is the type of each and every entry in this entry set? It's going to be map.entry. You can get rid of this type variables and let's call it entry. So basically what did we just do? If you take a look at the methods defined inside the map, you would see a sub interface. So what that means is whichever class implements that interface, it has to provide a subclass as well. If you're interested, you can go to grepcode.com and explore the source code of map and HashMap. and you would see a subclass in the HashMap, a subinterface in the map. So what is that subclass or subinterface meant for? It is for this type entry, and entry will have methods like getKey and getValue basically, and that way you'd be able to loop through all these entries, get the key and its corresponding value. So the type of each entry is the subclass type of the map. Let's do sys out. Now you can say key plus entry.getKey. So these are the methods that are residing inside that subclass. We got the key. Now let's try to print the value associated with it. Value is entry.getValue. Let's run the program. Let's comment this code out. Key value, and key value. Pretty well and good. Also, you can have null as a key, but just as any other key, you can't have a duplicate of it. So you can add one null key, have some value. Let's run the program. Key null, but do take a note, null is inserted at the top of each and every element. Anyway, it's never a good idea to have null as a key unless there is a good business reason, but I don't know any of such reason why you should use null as a key. Now one last thing which I wanted to point out here is always try to have string as the key, because of one good reason. String is immutable. Once you define 100 as a key in here, nobody can ever change this value because string is immutable. For example, if you're trying to use your own class as key, let me just demonstrate that. So I'm going to make use of the class which we had already created, my own. I'm going to say the key type to be of my own, and now we can no longer have string as a key. My own of 10, whatever, and then my own of 20, again my own of 10, my own of 10. Now if you take a note, the keys for all these three entries in here are same. So essentially we should have only two entries, but let's see what's going to happen. Even though the keys are same, Java assumed it to be of different. The reason is the logic behind the put method is going to assume that there is duplicate key based on couple of criteria. Number one, it's going to check to see if object 1 equals object 2, and it's going to check to see if object 1 dot hashcode equals object 2 dot hashcode. Only if these two conditions are met will the map assume that it is dealing with duplicate keys. For example, let me just quickly move these into individual variables. My own O1 equals new of 10. Let's copy this. O2, O3 and O4. Let's make this 20, 30, 40. I'm going to pass in here O1, O2, O3 and O4. Now the hash code of each one of these objects are not identical. Also, the equals method doesn't return true. Let me just prove that. Sys out, and I'm going to say, for simplicity's sake, let's get rid of this. I'm going to say O1 and O2. Similarly in here, we're going to have a sysout statement. I'm going to say our hash code equals o2.hashcode. Let's comment this out for the time being. If I run the program, both are false. So somehow we need to tell on what basis are my own objects similar. And for that, I'm going to override a couple of methods. One is equals method, the other is the hash code. And I can certainly make use of the IDE functionality. Click on override implement methods, and you can simply choose the methods that you want to override. So in this case, equals and hash code. I'm going to set the hash code to be same as the value. So that way when I have two objects created with the same value, they both would have the same hash code. And similarly for equals, I'll get rid of the default logic. Rather, what I would do is I'll make sure this dot x equals object, and I'm going to typecast it to my own class dot x. If these two are similar, this has to be this argument, a quick fix there. So if these two are similar, then we would say the equals method is true. Now let's try to run the program. Of course, we need to have same values. Let's run the program. True and true, pretty well and good. And without these methods, this would be false and false. Let's undo. Now we can run the program and it would run smoothly, and you would see only two entries. Pretty well and good. Now if this sounds confusing, then you don't have to worry much. Just make sure you always use string as a key. But if you're using your own object, then make sure that you override both these methods, equals and hash code. And you cannot have just equals alone. You cannot get rid of hash code, for example. So that way one of these conditions is not going to met. So again, we'll see the issue. We're seeing three entries. Likewise, you cannot get rid of the equals method either. Inappropriate results. So always make sure whenever you override either of these methods, always override both. It's a very good design practice. Let's undo all these changes. You can also explore other implementations like tree map, linked HashMap, etc. But HashMap is a very popular one and is extensively used in the Java world for one good reason: performance. But no matter what implementation you use, it has to provide functionality for put, get, and a lot of other methods. You can always explore the methods defined inside this interface or the implemented class in your Eclipse IDE. Read the description and play around with it. Alright, that's it on map. See you in my next video. In this video, we're going to talk about queue and dequeue. A queue is like a queue in a supermarket. The first person to enter the queue would be the first person to go out. That means it follows first in, first out approach. The first one to come in is the first one to go out. And queue in programming world is no exception. So we have a queue interface and its implementation, LinkedList. We have a couple of more popular implementations apart from LinkedList, but nonetheless LinkedList will always serve the purpose. So what we're doing here is we're trying to add elements into the queue. It's like adding people into the queue. I'm just displaying the current elements in the queue, and in here when I do queue.element, I'm just trying to retrieve the first element that is currently residing in the queue. And after that, I call this method queue.remove, when I call remove, it's going to remove the first element in the queue. In this case, it's going to be apple because that's what entered first. So the first one that enters will be the first one to go out when we do remove. The next time you call remove, again it's going to remove the first element. And since apple has already left, it's going to be banana, which is going to leave. Similarly, on our third call to remove, it's going to remove the pineapple. The only thing that is left is mango, and that's what we're trying to display. Let's run the program. As simple as that. Similarly, we have a Dqueue, stands for double-ended queue. It is similar to a queue, except it will allow us to add and remove elements from both the ends of the queue. In this case, I have the Dqueue interface and again the linked list. So what this means is linked list implements the interface Dqueue as well as the queue, and it provides implementation for both these interfaces. So in here I'm just trying to add some elements, and in here I'm trying to use the method add first to add the element at the first, that means before the apple, and in here I'm adding at the last after mango. So at this point of time, if I try to print the current elements in the queue, it should start with added at first element and then apple, banana, pineapple, mango, and then the set of elements ends with added at last. And this statement would print the first element present in the current queue. We are removing 3 elements, so it's going to be this element first and then apple, banana. So we should see rest of the elements starting with pineapple. Let's run the program. There it is. Alright, that's it on queue and Dqueue. By the way, we haven't yet talked about the definition of a collection. All these kind of classes like LinkedList, ArrayList, HashMap or HashSet, etc., everything we talked about would constitute what? Collection of elements. And that's why we call these constructs as collections. A linked list is a collection, an array list is a collection, a hash set is a collection. Everything is collection of elements, except they differ in terms of how they deal with elements. Soon, maybe after a couple of videos, we're going to take a look at the big picture of how these classes are organized, their parent classes, and which class implements what, and that way you'll be clear on the overall big picture. See you in my next video. In this video, we're going to talk about some of the pre-existing algorithms that we can make use of to perform a variety of operations on collections. In this case, we're going to consider ArrayList for demonstration purpose, and all the algorithms that I'm talking about were part of a class called collections. And we're going to perform operations like sorting, which will sort the elements of an array list in a particular order, searching, which will enable us to search an element in the list, and shuffle, which will shuffle all the elements in the list. Likewise, we have few other algorithms that you can make use of to do a variety of things. In this example, I just have one method which will just return an array list, and every time I make use of one of those algorithms, I'm getting a fresh list by calling this method. So in this section, what I'm doing here is I got the array list and I'm passing that argument to a method called sort of collections. By default, it's going to sort all the elements in ascending order if the list constitute integers or double any numeric value. If it is a string, then it's going to sort all the elements in alphabetical order. Since we're sending a string, this is going to sort all the elements in alphabetical order, and that's what we're doing here. If you wanted to do it the other way, if you wanted to sort the elements in reverse, or for integers it's going to be in descending order, then you're going to pass another argument which is this collections dot reverse order. So basically the sort method is going to accept a variety of arguments. One is single argument, which is simply a list. The other one is along with a comparator, which we'll talk about in a minute. But basically this instruction will actually sort in ascending order, and it will reverse it out so that we get the reverse order. Let's try to run the program. Let me just comment out this section of code. So list before sorting, this is how it looked. Ascending order, and the reverse of it, which would be descending order. Let's uncomment. Let's comment this section. Now I got a fresh list of strings again in here, and this time I'm trying to search an element, and for that I'm going to call this method binary search, which is a static method of the collections class. It's going to accept a couple of parameters. Number one, the list in which you want it to perform the search operation and the element that you want to search. This will return us the index. Let's run the program and see the result. So it's at index 1, index 0, index 1. Similarly, you can shuffle all the elements in the list. So let's run this program. We're just calling the shuffle method and we're passing the list. There it is. The list is shuffled. And every time you run, the result would be different. Obviously, that's the intent of shuffling the elements. So these are some of the predefined algorithms. Likewise, there are a few more if you wanted to explore. You can just go to the documentation of the collections class and experiment with them. Let me uncomment everything. Now you may have a question arising in your mind. How do we deal with list that has our own custom objects? How does these algorithms know how to sort our objects or how to search an element, etc.? The answer is it doesn't know. We need to tell how to deal with our own objects. We'll see an example of it in our next video. See you in my next video. Alright, in the last video I left you with the question mark in your mind. So let me just bring clarity on that. In this example I have created a class called dog, and it has a couple of variables, height and the name of the dog. I also have a constructor to set the initial state for the dog object, and I've also overridden the method toString so that when you try to display these dog objects you would see something readable, not the hash code. In our main class I have created 3 objects of dog, and I've added each one of those elements into list that can constitute list of dogs, and in here I'm trying to perform sort on this list. Obviously, as you would expect, we have an error because the sort algorithm does not know on what basis should my elements be sorted. So sort algorithm is kind of confused. So we need to do something to let the sort algorithm know the criteria under which my list should be sorted. Let me just simply print this list by commenting this line first, and then there it is. Let's uncomment. Now what the sort algorithm expects us to do is, whichever the type of element that you add in the list, if you want that list to be sortable, then you need to implement an interface called comparable. In this case it's instances of dog, so let's say implement comparable. It's going to accept one generic parameter. In this case it's going to be of type dog. Obviously we need to implement all the unimplemented methods. It's just one single method, which is compare2, and we need to have some kind of a logic in here that will help the sort algorithm to sort our elements. In this case I want to sort all my dog elements based on their height. So the way I tell it is I'm going to say this dot height minus object dot height. Of course, we need to return this. Now guess what? This will do the magic. Our elements will be sorted based on the height in ascending order. Now I agree the fact that this instruction is not making complete sense, but in order to understand this, we need to understand how the sort algorithm works to make complete sense out of this instruction. But just remember, as a rule of thumb, if you wanted to sort based on int, which in this case is height, then you want to do it this way. This instruction will sort all the elements based on the height in ascending order. If you want the list to be sorted in descending order, you want to swap these two. You want to do object.height minus this.height. But I wanted to sort these elements in ascending order. So let's just undo that and save the file. Guess what? That's all there is to it. Let's run the program, and list is sorted based on the height 10, 20, 30. Alright, fair enough. Now let's say at later point of time in the code, somehow I want my list to be sorted based on the name. How do we deal with that? Since we have already overridden the method compare2, we cannot have another compare2 method and provide instruction to sort elements based on the dog name. So what we can do is we can create a class and implement an interface called comparator. Instead of creating a new class and implementing comparator, we can certainly make use of, guess what, anonymous class. If you don't know what is anonymous class, I would recommend you to go back and take a look at my video on that. So in here, I'm going to create an anonymous class of comparator, not comparable. This is going to be of type dog. I'm going to name it as sort by name equals new comparator. And when I hit enter, our Eclipse IDE is going to do the job for us. It's going to create an anonymous class by overriding the only method which is present in this interface. So in here we'll have our logic. So since the name is not an integer, we can't have a logic that is similar to this. What we need to have though is we need to make use of the compare2 method, the exact method compare2 of the string class. Let's see how we can make use of it. So I'm going to say o1 dot name dot compare2 o2 dot name. Now this will sort all our elements in alphabetical order. If you want to sort them in reverse order, then you want to swap these two. You want o2 dot name here and o1 dot name here. Let's undo. Now all you have to do is you need to pass this as an argument to the sort method, like so, and that's all there is to it. So with this instruction we'll actually sort all the elements based on their height first, and then it will sort all the elements based on the name in alphabetical order. So ultimately we should see a list with elements sorted in alphabetical order. Let's run the program. There you have it. Again, this instruction may not be making complete sense at this point of time, but just be aware of how to use that. That should suffice for now. Alright, that's it. In this video, we're going to take a look at the big picture of the entire collection framework. Let me just quickly credit this website. It's videos.web, whatever it is. Basically, I found this in Google. If I were to draw the big picture of the entire collection framework, this is how it would look. At first glance, this might look a little overwhelming, but trust me, we've already talked about majority of these classes, or in fact, maybe everything. So we've talked about interfaces like set, list, queue, and map, and their implementations like HashSet, ArrayList, vector, and LinkedList. We've talked about the HashMap, etc. Basically, these are all implementations of these interfaces. For example, if you talk about HashSet, linked HashSet, and TreeSet, the job of them is same. They have to provide the functionality of set, and so they're all implementing the set interface. So by the end of the day, no matter what implementation you use, as long as it implements the set interface, it's going to have to provide the functionality of set. But what they differ from each other is the mechanism in which they deal with elements and the performance aspect. You need to go through the documentation of all these implementations and see which one would be best fit for you. But as I always mention, as a good practice, if you have reference type as an interface, you always have the freedom to switch between all these implementations with very less damage. And guess what? That's all there is to it. And we have the collection interface, which is like the parent of all these interfaces. Also take in note that collection is an interface, and this shouldn't be confused with collections, which is a class. Collections is a class that has all the algorithms that we've talked about in last couple of videos. So I guess that's all there is to it, and that's it. See you in my next video.
Let's talk about the factory methods which are introduced in Java version 9. Let's say that I'd like to create an immutable list. Now before Java 9, this is how I'm supposed to do it. I'm going to first create a list, and this is going to hold a list of string elements. We provide the implementation, and the statement. I'll do Ctrl+Shift+O to import required classes and interfaces. And once we have this, we can then add list of elements. I'm just simply going to add some random elements. Maybe apple, whatever, it doesn't matter. And then finally, we need to convert this list into an immutable list by using one of the methods of collections. Unmodifiable list, and we provide list as the argument. I'll do sysout and then finally display the list. This obviously runs, and the fact that this is immutable, if you try to add another element, you're going to see an error. Okay, it says unsupported operation exception. However, with factory methods, which are introduced in Java version 9, we don't have to write so many lines of code. This is very verbose. Instead, we can bring everything in here to a single line. We can actually accomplish the same by using lambda expressions, but you need to sacrifice on readability. Let's use one of the factory methods and see how it works. I'm going to say list.off. This is a static method. I don't have to create an instance to call it. And we have multiple variants of this method. Since we're going to pass 3 arguments, I'm going to choose this method and pass those 3 arguments. Apple, banana, and pineapple. Let's sys out this, save the file, and this should give us the same result. And this list is also immutable, so if you try to modify the list by maybe adding an element, then you're going to see the same error. So what have we accomplished with the factory methods here? One thing that is very evident here is that we were able to reduce the number of lines of code, but apart from that, our list is also immutable. And another thing which is quite significant is that we didn't explicitly mention the implementation of list. It's taken care automatically, meaning that the factory method is designed to pick the best implementation depending on the number of arguments that you provide. So that's another advantage in using the factory methods. We have factory methods for other collections as well, like set, map, etc. And for map, you need to provide the key value pairs. Let me try to show it. You can say map of, and you can provide the arguments in the form of key value pairs. So if you were to add 2 elements in the map, you have to provide 4 arguments.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.